So hopefully we can do this pretty quickly. But again, these are definitely the powers you want to know. They're going to be very helpful for you. So if you haven't finished these, all these powers, then finish them, when we're done. It's fine. You also have calculators. So everything today can be done using your calculator, pretty much. Okay. All the evaluate you can use your calculator on. So we're not going to, but I'm going to show you how to use your calculator to do it. Okay. So today we're just learning some new notation, and after notes, I'm going to need you guys to go, I have the computers out, you can see. I need you to do the school quality surveys in School City. All right, so you guys can, after notes, go up and open up a laptop and log in School City, and then find the survey that you need to take. Okay. Rational exponent properties. Rational exponent properties. I don't know. This is really important here. A to the P over N. Rational exponent. So it turns out that all on that first page, all the things you saw were the exponent, the superscript number, the high number, that all those were what we call integers. Integers are positive and negative whole numbers. So they were nice looking numbers. But it turns out that we can have rational fractional exponents, okay? And rational fractional exponents are actually roots and powers. So I'm going to give you an example. So a number to a p power over n can be rewritten with radicals, and that's nice because it's going to help us evaluate. So let's see how that works. If I have like 2 to the 4/5, so you can see this 2 is what we call the base. And here we have what is called a rational exponent, so a fractional exponent. Then 2 to the 4/5 can be rewritten. I lovingly call this the power P, and the index, N, is the bottom number, index. The index is the number in the little elbow of a square root, but it's not called a square root. Now this is called a fifth root, okay, because of the index. So if it was a 6 in the elbow, we'd say a 6th root. Or a 3 in the elbow, we'd say a 3rd root or a cube root, okay? And then we will have the base underneath, and that is all to the power of 4. So it's kind of nice. So you need to know that it's power over index. Power over index. And index is the number in the elbow. The power is on the outside. All right. This is a little bit of information we will get to a little bit later. Your calculators will help you out with this today. If n is odd, then it has one real root, one real answer. If the index is odd, there's always one answer. But if the index is even, so if it's an even answer, then we might get 2 answers, a positive and a negative answer, when we're solving for x. So it doesn't apply to us today, but it will in the future. I want to show you how to use your calculators to evaluate these. So get out your calculators. I'll do it both ways. So to use your calculators here, the 5th root of negative 244. If you have a TI, the 5th root is under the math menu. And under the math menu right here, and you can see that there's an xth root. That's number 5 is the xth root. And you could put a number in there, but you'd need to change that to a 5. And then you can type in negative 244. And it's going to give you a decimal answer, negative 3.00 approximately negative 3.0024 something rather. Okay. 2465. So let's see on our Casios, I'm going to go to the math menu, and we should have, there it is. It's in yellow. It's right above that little caret function there, little caret. It's yellow, so you're going to do second or shift, and then that key, and you can see that it puts A and S. That's the previous answer. I'm going to change that to a 5. There you go. The fifth root of, I'm going to use parentheses. I want to make sure it's underneath that. So the fifth root of negative 244, and I did put that in parentheses because this calculator, I'm just not quite sure. And we get negative 3.002465. Okay. Here we have 32 to the 5/2 power. Again, that's really easy to do, easier, I think, than the roots. But we're just going to make sure we put our exponent in parentheses, and it's going to work really nicely on both calculators. For ones written like this, we can just use the little caret button. So we can do 32 caret. Oh, you see how that's in parentheses? Let's do that. Parentheses 32 caret, and I'm going to do 5 divided by 2. So that the calculator knows that the 5 and the 2 need to be up in the exponent position. Okay. Big number there. I'm going to do it on this calculator as well. 32 caret 5. You don't really need the parentheses on this guy if it's written like this, but it's safe to use the parentheses. It's never hurts. So 5792.6 for both of those. On and on and on. Crazy numbers, right? Okay. So you can use your calculator. It's important to know how to do that. Any questions on that so far? We'll do some more. So here we go. Example 1, write the expression in radical form. Again, make sure that you're writing the directions down. Write the expression in radical form. Okay. Okay, so write the expression in radical form. So right now these are rational exponents. And so we have a base of 6, and we have a power of 1 and an index of 3. And so if I want to write that in radical form, then that's with the root. What goes in the elbow? 3. The index goes in the elbow. And the base is 6, and then the power goes on the outside. Do I really need that power of 1? No, it's not doing anything. So just the cube root of 6 is fine. Either one of those is fine. You need to know that they're equal to one another. They mean the same thing. All right, 10 to the 3/7. What number goes in the elbow? The 7. And then the power would be 3. So power over index, power over index. And then we have a base of 5. So that's underneath the radical. What goes in the elbow?
5.
And the power is 2. All right, power over index. Power over index. Have I said it enough yet? What is it?
Power
index. Okay. Good. Example 2. Write the expression using rational exponents. So this time we want to just see exponents, no more radical. Write the expression using rational exponents. Write the expression using rational exponents. So on the first one here, what's the power? 1. Very good. So there is a little imaginary power of 1 there. So our base is 14. So how do we write the exponent? 1 over 4. Power over index. Good. All right, letter B is the 7th root of 5 quantity squared. That's how you would read that out loud. The 7th root of 5 quantity squared. What's the base? 5. So how does the exponent go? 2 over 7. Very good. Power over index. Ooh, this one's tricky. This one's a fraction. What gives us fractions? The negative exponent. Very good. Because this is a fraction, we're going to have a negative exponent. That's important to think about. All right. What's the base here? 16. What's the exponent going to be? Power over index is going to be 5. Oh, 5 over 9. Sorry, I misheard you. Okay, and then how do we make it turn into a fraction?
Over 1.
Negative exponent creates that fraction. So that's something to think about. Negative exponent turns it into a fraction. Crazy. Okay, any questions on those? That's very easy, right? That's like 80% of the worksheet. All right, these are a little bit harder. Example 3, evaluate the expression without using a calculator. That's what the directions say, but you certainly could use a calculator. You're allowed a calculator all the time, so you could take advantage of it. We are going to work through these by hand, but then we'll check them using our calculator, okay? So evaluate the expression without using a calculator. Evaluate means find the value. We want a number answer, okay? We want to know what does it equal if you simplify it. So I'm not very good with rational exponents. I'm better with radicals. So have you finished writing directions? Are you with me? 81 to the 1/4 power. All right, I'm going to go ahead and convert that into radical form. So the base is 81, and what's the index in my, so power over index, so the index is 4. So this is saying, what is the 4th root of 81? What is the 4th root of 81? Do you know what that means? So it goes back to our powers. So let's look at our powers sheet here. Do you have an 81 somewhere in here? Which one equals 81? 3 to the 4th equals 81. So if 3 to the 4th equals 81, radicals undo those powers. So then the 4th root, of that 81 is going to equal the base 3. Okay, so powers and radicals undo one another, and so if you know your powers, then you're going to know your roots. So the 4th root of 81 turns out to be 3. All right, and it's because 3 to the 4th power equals 81. There's an E on the end of that. Okay, so we get 3. I can check that really easy on my calculator. I can say 81 caret 1 divided by 4, and I get 3. All right, so super easy to check on your calculator. All right, so here I have, ooh, this one's harder. Negative 8 to the 5/3 power. So my base is negative 8. What's going in the index here? 3. So that's like the cubed root of 8, or the cubed root of negative 8, and then to the 5th power. So what we're going to do is we're going to work inside the parentheses first. Does anyone know what the cubed root of negative 8 is? Okay, so is it 2 or is it negative 2? Yeah. So negative 2 to the 3rd power means negative 2 times negative 2 times negative 2, which is negative 8. So negative 2 to the 3rd power equals negative 8, which means that the cube root of negative 8 equals negative 2. So inside here we have a negative 2, and then we're taking that to the 5th power. What is negative 2 to the 5th power? Negative 32. Very good. 2 to the 5th is 32, but we have an uneven number of negatives, an odd number of negatives, so we're going to have a negative result. Can you check this on your calculator? Absolutely. All right, last one here. Negative 27 quantity to the 4/3 power. So I'm going to rewrite that using radicals. So my base is negative 27 underneath the radical. What's the index? 3. And then we're raising it to the 4th power. Very good. So this is the cubed root of negative 27. So I don't have any negatives on our sheet, but where do we see the number 27? 3 cubed, huh? 27? 3 cubed is 27? Okay. So how do we get negative 27? Negative 3 cubed is negative 27. Very good. Which means the cube root of negative 27 equals negative 3. Good. So negative 3 to the 4th power. Is this going to have a positive or a negative result? Positive result, because there's going to be an even number of negatives. All right. And what is 3 to the 4th power? 81. And that one is from your sheet there. So again, all of these you can use your calculator for. So don't freak out. Just, when in doubt, plug it out on your calculator. Okay. All right. All right. Do you have any questions for me? Okay. You guys,